All right, hey everybody. I am not in the building today, so everybody is on their own watching this video. And this video is to go along with your packet, and it's going to start with page 5, y'all. And today we're going to be talking about how to use our proportions, which we've definitely covered in the past, and I'll be reviewing a little bit today. And we're going to be using those proportions to just find a missing side when we're looking at similar quadrilaterals and then triangles. We're going to start with quadrilaterals here on the front. And then when we go to page 6, we're going to be talking about similar triangles. Okay? So we've already covered what the definition of similar is. It means they have the same shape, but they're just a different size. Now, in our last class, the thing that we covered here, y'all, was that angle A, for example, would correspond over here to angle E. Notice that the longer side here is in yellow and the longer side here is in yellow, and then I have the shorter side here highlighted in green. So go ahead and be taking notes. You want to be taking notes today as I'm going through the video. You want to be filling this stuff in. So anything you see filled in here, you want to take notes on, and then I'll be also filling some stuff in along the way with you guys, okay? All right, so we've already covered again that angle A goes with angle E. We see that B would be with H. We see that C would be with G. And then we see that angles D and angles F are corresponding, okay? So corresponding from our last class, remember that just means it's in the same spot. So then which side is in the same spot as AB? Well, AB, we're going to go from E to H. Which side is in the same spot? Again, that's what corresponding means for BC. That's side HG. CD, along the bottom here from C to D, we're going from G to F. So I've got GF. And then from D to A, so from F to E. Friendly reminder, you guys, that in your communication in the language of algebra, that you want to use these angle symbols. Those are angle symbols. And then you want to use the line up here to show me that you're talking about a side, okay? Now our goal is to figure out what this green side would be over here. There are lots of ways to pull this off. And that's what we're going to be doing in this box. We're going to talk about a lot of different options, and then we're just going to pick one over here to solve. Now, another key thing I wanted to review before we talk about today's I can statement was that in our last class, we talked about this thing called a similarity statement. So I wanted to review with you guys that you can write these for yourselves and say, okay, I'm dealing with a quadrilateral, so I'm just going to draw like a little rectangle or a little square. And I'm going to call the first one quadrilateral A, B, C, D. I'm just going around clockwise and saying, okay, I've got quadrilateral A, B, C, D. Okay? Now, the whole point of this process was that you know angle E and A are in the same spot. So you can just read this one clockwise, E, H, G, F. So we've got quadrilateral E, H, G, F. Go ahead and take notes with me on this one. So EHGF. And remember, the whole point of this is that they're similar, so we're going to use that little squiggle symbol. If they were equal, congruent shapes, then we'd put that equal line up underneath it, but they're not. They're similar figures, okay? So when I ask you guys how we can look at these shapes, several of you are going to see that this green shape and this yellow shape, you're going to kind of see this unknown side, and then you're going to kind of see the 26, which means you're kind of comparing here, and give me a sec to kind of show you what all the options are. Don't worry about copying down quite yet. But I'm saying here you're comparing the green side to the yellow side. So then another option would be to compare the green side to the yellow side for the next shape. So the green side here is a 15, and its yellow side is a 39. So some people see the shapes that way, okay? They see color to color within one shape. And this is a possible proportion that we can solve to figure out what X is, all right? Now, another way some of you are going to see this shape, these two shapes, is some of you are going to see, well, this green side got a little bit bigger. So the green side kind of turned into a 15. So you're comparing green to green. And then you're thinking the 26 turned into a 39. Now you're comparing yellow to yellow. So 26 to 39. And these are two possible proportions, you guys, that we can cross multiply and solve to figure out what this side length X has to be. All right. Now, again, some of you see, I just kind of want to compare the two of them now. And let me draw like maybe like a little squiggly line to kind of divide the two. All right, so one way to read these shapes is seeing green to yellow and then green to yellow, which is over here. Or you can see green to green, yellow to yellow. Doesn't matter how your brain likes to think about this, because notice when we cross multiply to solve this, y'all, both of them are going to be multiplying a 26 times a 15. Here's 26 times 15 in your calculator, okay? So we've got 26 times 15, and then we're going to be dividing that answer by a 39 in both cases. So it really does not matter how your brain likes to think about this. You can just pick one of these. And at this time, I'm going to give you a moment to just pick either this one to take notes on over here or pick this one to put over here, whichever one you think you like a little bit better. And as you guys are deciding, another thing I'll point out is that you could see yellow to green and then yellow to green. So even doing the 26 over the X, again, I'm seeing yellow over green. So 26 over X, and then this yellow over this green is a 39 over a 15. And again, you can see when I cross multiply, there's my 26 times 15. It still matches up. And then I'm going to be dividing that answer by a 39. Okay. So again, doesn't matter which of these you prefer. And I'm just going to open up my calculator. If it'll let me, maybe not. Here we go. All right. So again, what we said we're doing, y'all, is 26 times 15. We're going to cross multiply the two numbers that we have, and then we're going to divide by a 39. And we get a 10. So if X is 10, this side length has to be a 10. Okay? X would be a 10. The side length would be a 10. And what we just did was we used a proportion, any one of these, we used one of them to find the missing side. And go back to the I can statement for today. We just solved the proportion to find the missing side length of two similar, in this case, quadrilaterals. Okay? All right. Now, if you need to pause the video, friendly reminder, you can always pause the video, you guys, at any given point to take notes if you want to. You can also pause the video if you want to try this one on your own and then kind of hit play and skip ahead to see if you did everything right. But for this one, the good news is that these shapes are turned the same way as each other. We've got this long side 30 matches with this long side 15. And the shorter side Y matches with this side 12. And I'm going to change that one to a blue just to kind of help you see the matching sides. All right, so easy breezy. I'm just going to go ahead and put all my angle symbols here. All right, we got all of our angles. So A goes with R. B is in the same spot as U. C is in the same spot as T. And D is in the same spot as S. Okay? And now when we're talking about our sides, I'm just going to go ahead and put the side symbols up above so I don't forget about them. All right, so A to B would be R to U, so RU. B to C would be UT. Again, this is our last I can statement, being able to identify corresponding sides and angles. If we're going from C to D, that's TS. And then DA would be SR. All right, cool. So we've got quadrilateral ABCD, and this is a parallelogram, so I'm just going to kind of sketch a parallelogram symbol. That's really bad, but that's okay. So parallelogram ABCD is similar to parallelogram RUTS. All right, sweet. Now again, with this one, lots of ways to compare these, y'all. You could be blue over red, so then blue over red would be a Y over 30 on this one. And then over here, blue over red would be the 12 over the 15. And I do think that this way is a very common way for a lot of people to read these shapes. They're definitely thinking like blue to red, blue to red. But I think this example does a really good job of pointing out why some people's brains might actually go from one shape to the next, because check this out. If you go from red to red, right there you can catch that 30 gets cut in half to be this 15. So this shape over here is half the size, all right? So again, that's one reason why a lot of people's brains will work this way, so the 30 to the 15. and then blue to blue, so the Y gets cut in half to be a 12. All right. And some of you, your brains might prefer to see it the other way. Some of you think about, oh, okay, this 15 goes to a 30. So then this 12 is going to double to be a 24. So this is definitely going to be a 24. This is for sure a 24. Again, I want you guys to, right here, pick the one. I'd like for you to have both in your notes over here, but I'd like for you to pick the one that you think your brain likes better, okay? Do you think that you're just going to always want to go blue to red, kind of blue to red, which is this first one? And notice you're going to cross multiply. 12 times 30 is 360. And when you divide that here by a 15, we do get a 24. So this 12 times, let me pull my calculator back up. Should have closed out last time. Sorry, y'all. All right, so again, I just said the 12 times 30. That's that 360. And when I divide it by the 15, so I get the 24 when I solve my proportion, which is today's I can statement. And for lots of you, you can definitely see this one very quickly in your brains, which is awesome. All right. So we're going to get a 24 here for this one. Y equals 24. That side length would be a 24. Okay. So this 30 got cut in half to be a 15. 24 would be cut in half to be a 12. That's one way to think about it. Or you can say the 15 got doubled to be the 30. So the 12 doubles to be a 24. Okay. So pick whatever one of these you want and just write that one over here. Just pick which one of these you want to go over here for the way your brain likes to think of the proportion. Okay. All right, so that takes care of page 5. We're done with the quadrilaterals. Nice. All right, let's flip over to page 6. And on page 6 here, we're going to be taking a look at these triangles. Okay. Now, I wanted to review briefly with you guys that the only catch sometimes is that the shapes might be turned around a little bit differently. So with the shape that has numbers, notice that this one's the longer side, and then here in yellow, this one's the shorter side. Now on this one, I think we would agree that this one's that longer side, and then here, this one's the shorter side. So they're just kind of mirror imaged a little bit. But that at least helps us to see that if you want, I kind of think it's helpful to redraw. Like I'm just going to redraw this one, the bigger one. I'm just going to redraw it turned the same way. I just looked at this shape and drew a bigger version of it and then said, okay, I know that this is the yellow side and I know that this is the blue side. So now I can put my letters there. So the blue side is K to M. So this one's a K and this is an M. And then the A goes down to B. So K goes down to L. All right. And the KL side was a 15 and the KM side was a 27. So I personally prefer this method right here because, and then it allows me to just see the sides more clearly. But if you do not need to take that step of redrawing the shape to compare this shape now to this one, great. Some of you can compare this one to this one when it's flip-flop. That's awesome. But A is in the same spot as angle K. That's up top. Then C and M are in the same spot. And then over here, B and L were in the same spot, angle L. And then A down to B would be K down to L. So we got side KL. A to C is over here, and that's K to M. So side KM. And then B over here to C would be LM. So our similarity statement, this time when we're dealing with triangles, you can just draw the triangle here, and we're just going to say triangle A. Now notice with this one, y'all see how when you go around, it's not in alphabetical order anymore, and that's okay. You can say ACB. If you do ACB, that's okay. And you'll just tell me it's similar to KML. Triangle KML. That works. You can also say, okay, well, I'm just going to go the other way. Even though normally in math we go around clockwise, but it is acceptable for some people who are like, I want this to say ABC. If you want this to kind of feel more in order for ABC, then you're going A to B to C. So now you're just going to tell me it's K to L to M. So just make sure that they line up, K to L to M. So whichever one of these that your brain likes better, awesome. At least it means that you know the whole point of this similarity statement is that the numbers should be in the matching spots. And in both cases, they are, so we're good to go. All right, again, for this one, pick whichever one makes more sense to you, y'all. Some of you are going to say, okay, I see yellow to blue, so I'm going to put my x over 12. And then my yellow to blue here is a 15 to 27. Some of you are going to see it this way. Others of you are going to say, I see yellow to yellow, so you're going to put an x over 15. And now I see blue to blue, so a 12 over a 27. Does not matter which proportion you prefer, because in both cases, we are cross multiplying a 12 times a 15, and then we're going to be dividing by a 27, okay? So 12 times the 15, let's pull that up real quick. So 12 times 15 is going to be 180. Now I'm going to divide by the 27. All right, cool. And we get a decimal here. And since I don't want the decimal to be rounded, the 6.6 repeating, you guys might remember this. This is a good review of something from earlier. This would be a 6 2/3. Let's write the fraction of it. It'd be a 6 2/3. Okay. All right. Now I'm sorry, I want to go back to that real quick. It is okay for things to be fractions and decimals, y'all. You guys are getting a little bit older. These sorts of things are fair game. So just kind of keep that in mind, all right? Okay, now let's see. We've got, oh, this is one of the ones where we have a triangle within the triangle. So check it out. See this red thing? I'm just going to move it out. And it's basically, if I took this one, I can enlarge it. And the whole thing is that now I'm just shrinking it down. And it's the similar figure, but I'm just going to put it kind of inside the other shape, okay? So it is helpful, I think, for some people to just draw this kind of off to the side. You're kind of pulling the shape out, if you will. And then this, the C up here, this right here, it was the G. This, it'll share angle F. We'll just still call that angle F. And this bottom one was angle E. And I think even sometimes too, it's helpful if I can do this. Watch this. If I kind of white out this line here, now it's really easy to see the two shapes. That was the G up top. That was E down here. And so we've got a 3 and a 4 to label our sides. So we've got a 3 here. Whoops. 3. That's that 3. And then this was a 4. All right. So now I can highlight my corresponding sides. I'll let this one be a green side, and this will be a green side. And then we'll have yellow down here, and this will be a yellow. All right, let's get our corresponding stuff out of the way. So C up top goes with G. We've got our angles here. F down there was still with F. They're in the same spot. It's okay that they're both the same thing. And angles D and E. Those were the right angles. All right, my green side DC goes with EG. Don't forget your little lines. Tell me it's a side. All right, C down to F is G down to F. And that's the part that I do think for a lot of you that when the line is there and that the shapes are inside here, this longer one, whoops, sorry. Yep, that longer one got shrunk down to just be this right here, okay? So C to F got shrunk down and is now this little guy, which was G to F. And that's what we're saying right here. And the bottom, all the way D to F, got shrunk down to be this little guy, so E to F. All right, so our similarity statement, let's go around the clock. We've got C, F, D. We'll do triangle CFD. Again, that's the most common way to write these is kind of, oops, is going alphabetical order, CFD. All right, and then we've got GFE is similar to triangle GFE. All right, now for this one, I actually think most of us are going to see yellow to yellow Here's what I mean by that. I think most of us are going to catch that this 8 down here got shrunk down to be a 4. So if the 8 got shrunk down to be a 4, what number is getting shrunk down to be a 3? What number gets shrunk down to be a 3? And that would be a 6. So this has to be a 6. This 6 gets cut in half. This 8 got cut in half. Okay? So again, yellow to yellow, most of us are seeing that the 8 got cut down to a 4. So then we want to know Q gets cut down to a 3. Cross multiply. 8 times 3 is 24. Divide 24 by 4. And we prove Q equals 6. So that takes care of me walking you guys through. This was page 5, and this was page 6. And you guys are going to actually be doing page 7 here on your own now. This is going to be part of the work that you have to do today on your own. And it says at the top that we would review it together, but since I'm not with you guys, I made a Google form. So after you answer these 4 questions in your packet, after you do this work in your packet, you are going to submit the answers into a Google form so that you can have some feedback, so if you were right or wrong. And then you can just check Schoology in a moment. You can just check Schoology to get that form. Most of you are just going to do the paperwork right now, and then when you're done, that's when you go get the Google form. That's fine. Now, afterwards, after you guys submit the Google form, okay, this was a worksheet that for those of you who are at home right now, for those of you who are at home, I gave this to you on Wednesday, and that's why it says that you're going to be doing it at home, and you're going to turn it in Wednesday next week when you come back, okay? Now, several of you are actually in the building right now, and for those of you who are in the building right now, when you get done with this page and you've submitted this Google form, you're going to get this worksheet from the substitute, okay? And when you get this worksheet, notice that there's a place for you to just put what X equals. So let's do this first one together, okay? I see that side 12 here goes with side 3. So side 12 goes with side 3. And I see that side 20 goes with side X. So this is my proportion. And I'm going to cross multiply. 20 times 3 is 60. And now 60 divided by this 12 is going to be a 5. So X equals 5. Now, if you're catching here that the 12 gets divided by 4, here we're taking a fourth of the number. So just take a fourth of 20, and you'll also get that that's a 5. So it is okay to tell me, it is okay to jot down the 1/4 if that's how you're seeing it as well, and let me know that you see that we're still going to get a 5. All right. Now, if you're in the building, you are going to be turning this into the substitute when you're done. If you are in the building, you're turning this in. There is a front and a back, you guys. There is a front and a back here for practice. If you are at home right now watching this video, you're going to do this at home, and you're going to turn this into me next Wednesday when you can get back into school. All right. One other thing before you end this video is that in your last class, you should have completed this worksheet. This worksheet was page 4. So if you have not yet completed this, for those of you who are at home in our last class, please make sure that this page is also complete. All right. All right. That takes care of my video. Have a good day. Bye.